Given question, determine the reaction Ra in overhanging beam as shown in the diagram by virtual work method.
Part of the beam is extended after point B. So this is the case of overhanging beam. Uniformly distributed load 20 kN per meter is given over the span of 4 meter. Moment 40 kN meter is also given. And at the end of beam 20 kN load in downward direction is given. We have to find out the reactions at point A and at point B by virtual work method. So we will give the small displacement at point A. Now there are two unknown terms, that is the reaction at point A and reaction at point B. So when we give the small displacement at point A, then we have to keep the displacement at point B is equal to 0. Then this one unknown term RB will become 0. So how to give that? So we will give the displacement in vertical direction. So we will say that at this point A, displacement given is equal to delta y. Then at this point B, displacement is equal to 0. Now we have to find out the displacement at various points. Now if we observe uniformly distributed load, so it is 20 kN per meter. So what is the total load? For 1 meter load is 20 kN. So for 4 meter, because it is on the span of 4 meter, 20 multiplied by 4 kN load acts. Now what is the point of application of this load? So we know that for the uniformly distributed load, point of application of load is the middle point. So for 4 meter, middle point is at 2 meter. So we will say that this point C, that is the point of application of this load, is at 2 meter from both the sides. That is from this point A, it is 2 meter. So we have to find out the displacement at point C. Now if we observe here, moment is given. So here this clockwise direction is given. So for this moment we have to find out the angular displacement. Now we know that this beam A to this point E, beam AE is initially at horizontal position. Now we have displaced this beam in this direction. So what is the angular displacement? So if we observe, we have to find out the angle theta. So here is the angle theta. Now what is the direction of rotation? So originally this is at horizontal position and then it is getting rotated. So it is getting rotated about this point B in this direction. So this is the clockwise direction. Then this 20 kilonewton force is acting in the downward direction. So we have to also find out the displacement at this point E. Now sign convention is the important part. So we will first write here the sign convention. So forces in upward direction, we will give here positive sign. Forces which are in downward direction, we will give negative sign. Then the displacement in upward direction, that is the above this original position, we will give positive sign. So I will write here positive. And the displacement which is below this original position, we will give here negative sign. So I will give here negative sign. Now here moment is given, or we can say angular displacement we have to find out. So this is the rotational motion. So the this moment, that is 40 kilonewton meter, is in clockwise direction, or this angular displacement which is also in clockwise direction. So for clockwise direction we will give positive sign, and for anti-clockwise direction we will give negative sign. So suppose this 40 kilonewton meter is in anti-clockwise direction is mentioned in the question, then for this moment we have to use negative sign. So this is applicable for this moment as well as for the angular rotation. Now we will find out the displacement at various points. So at point A, what is the displacement? Displacement is delta y. So this is the displacement over from this point B if we measure 3 plus 3 plus 2 plus 2. That is for 10 meter displacement is delta y. So we have to write this. So for 10 meter displacement given is delta y. Now we have to measure this distance where the displacement is 0, that is from point B. So if we observe here for this 10 meter length displacement given is delta y. Now we have to measure this displacement at point C. So what is the displacement given at point C? So first we will measure the distance from B to C. So it is 3 plus 3, that is 6 plus 2, 8. For 8 meter, what is the displacement? So I will write here 8 meter and here is the question mark. So I will write x. So 10x is equal to 8 delta y. Therefore x is equal to 8 by 10. So 8 by 10 we will simplify this 4 by 5. Now we will find out displacement at point D. So point D is where this 40 kilonewton meter moment is given. So how to find out this displacement? So if we observe, we have to find out the value of theta. Now this displacement delta y is very small. So how we can write this theta? Theta is equal to delta y divided by this length. That is this from this point B where this beam is rotated, we have to take 3 plus 3 plus 2 plus 2, that is 10. So at point D theta is equal to, so here because this is the rotational displacement, I will write delta y by 10. Now we will find out the displacement at point E. So how to find out? So again here it is 0, at point B it is 0 and here is the point E. So if we observe, this point E is at 2 meter from this point B. So again for 2 meter, here is the question mark, that is x, because point E is at 2 meter from this point B. So for 10 meter delta y is given. So for 2 meter x, that is 10x is equal to 2 into delta y. So x is equal to 2 by 10, that is equal to 1 by 5. 1 by 5 delta y. But now if we observe, it is in the downward direction. So we will give here minus sign. Minus 1 by 5 delta y. Now we will apply virtual work method. We have to multiply forces with its displacement and we will add all these forces and equate it to 0. If we observe the first force, that is the reaction at point A, which is in vertical direction, so it is plus Ra multiplied by displacement delta y. So we will take Ra into delta y. Now the second force is 20 multiplied by 4 kilonewton and its displacement is 4 by 5 delta y. Now this force is in downward direction, so we will take minus 20 into 4 multiplied by 4 by 5 delta y. Now next, if we observe, here is the moment. So this moment is 40 kilonewton meter and its displacement is delta y by 10. Now this moment is in clockwise direction, so it is having plus sign, and this angular displacement theta is also in clockwise direction. So we have converted this theta in terms of delta and it is equal to delta y by 10. So it is also having positive sign. So we will take 40 multiplied by delta y by 10. Now at point B, displacement is 0, so Rb multiplied by 0. Now if we observe the next force, then it is 20 kilonewton, direction is in the downward direction. So we will take minus 20 multiplied by, this displacement is below the original position, so it is minus 1 by 5 into delta y. So this minus minus will become plus. Now next step is to take delta y as a common term. So we know that delta y is not equal to 0. So we can transfer this delta y to the right hand side and it will become 0. So we will solve this. Then it is Ra minus 320 by 5 plus 4 plus 2.5 is equal to 0. So Ra is equal to 59.6 kilonewton.